So we're going to look at molecules today that have some dot structures that are also going to have some multiple bonds in them. We're going to start with a compound SiS2. And just like we did before, you're still going to look at each individual atom and see how many electrons they're going to need to get their outer shell full. So silicon is in the same column as carbon, and it's going to have 4 electrons, and so it needs 4 more. Sulfur is in the same column as oxygen, and sulfur has 6 electrons, and it will need 2 more. And so, just like I mentioned before, generally the atom that needs the most number of electrons is going to be the one that's going to go in the middle. So I'm going to assume at this point that that's the way it's going to happen, and I'm going to stick this sulfur over here like that, and then we're going to start connecting some things together. So let's assume that this silicon and this sulfur will share, and this silicon and this sulfur will share. So I've got everything hooked, so everything should be fine, right? Well, remember, the next step is always to count and make sure that everybody has an octet, so let's do that. If I look at this sulfur, I have 2, 4, 6, 7. Uh-oh, he's not obeying the octet rule, so he's not completely stable and he's not satisfied. This sulfur is in the same boat. He only has 7. How about the silicon? Well, he has 2, 4, 5, 6. He only has 6 electrons, so he is not satisfied either. So what am I going to do? Well, if these two guys will share these 2 electrons here in between them and make a double bond, and here I have another electron and another one up here. If I share those 2 together and make a double bond here, now let's go back and let's count electrons. So my sulfur is going to have 2, 4, 6, 8. Remember that every line is a shared pair, so it counts as 2. This sulfur is also going to have 2, 4, 6, 8. And then my silicon is going to have 2, 4, 6, 8. So now everything here obeys the octet rule and should be good and stable. Let's look at C2H2. Okay, carbon has 4 electrons, so it needs 4 more. And hydrogen just needs 1. And so since I need more electrons on the carbon, hydrogen's almost always going to be tucked somewhere on an end because it only needs 1 more. So likely this other carbon is going to join to this carbon, and we'll probably stick this hydrogen out here on the end. We'll put it together. We'll see if it all works this way. So initially, I've got carbon and hydrogen will be bonded together. I can bond these 2 carbons together. Is everything satisfied? Well, the hydrogen has 2, and this hydrogen has 2, so they're happy. They only need 2, but my carbon has 2, 4, 5, 6, and this carbon as well only has 2, 4, 5, 6. So the carbon is not yet happy. It does not have an octet. So I have 2 more electrons that I can share here between the 2 of them. So if I share those 2, I can make another bond. Did that take care of it? 2, 4, 6, 7. You're still not happy. So there's 1 more electron up here on both sides that I can share and make a triple bond in the middle. So now each carbon has 2, 4, 6, 8, and this one also has 8. So now I'm to the point where everything is content and happy and stable here. Now you might be asking me the question, or maybe you didn't think of this, could I have taken this hydrogen and stuck it on this carbon? A lot of Lewis dot structures are trial and error. So if you try that, there's nothing wrong with trying it, but that's why pencils have erasers. And you'll find that if you try to stick this hydrogen here, you may get this carbon to satisfy the octet rule, but you won't be able to get this carbon to satisfy it. So normally something like this is going to look pretty symmetrical. So that will hopefully enable you to get the right structure when you try it for the first time. So let's try C2H4. Again, carbon and hydrogen, but here I've got 2 more hydrogens than I had in this compound. So we look very similar. I'm going to take those hydrogens and I'm going to split them evenly between the carbon and see if that will give me a structure that works. So put the 2 carbons next to each other just like I did before, and I'm going to give 2 hydrogens to one carbon and 2 hydrogens to the other. So if I share these 2 electrons, make a bond. If I share these 2 and make a bond, share these 2, share these 2, and then if I share an electron between the 2 carbons, I now have everything hooked together. But as you can see, although my hydrogens are content because they each have 2, my carbons have 2, 4, 6, 7 electrons, and they're still an electron short. So if I take the 2 lone electrons that are still left and I share the 2 of them, then I will have a double bond between my 2 carbons. So 2, 4, 6, 8, 2, 4, 6, 8 for each one of the carbons. So now everything is satisfied in this molecule. How about if I do something like CsCl2, okay? Think about what each one of these needs. The chlorine is in the 7A column. It has 7 electrons, so it needs 1 electron to be satisfied. The sulfur we did up here, he has 6 electrons. He needs 2 more. So the chlorine needs 1, the sulfur needs 2. We've had carbon in several compounds now. It has 4 and it needs 4. So the carbon is the one that needs the most, and so likely the carbon's going to be the one that's going to get stuck in the middle. So let's go ahead and make that assumption that we're going to put the carbon in the middle with its 4 electrons. Let's put the chlorine over here on one side. It has 7 electrons, and if I share 1 with the carbon, my chlorine now has 2, 4, 6, 8, and he's happy. Okay, I have 2 chlorines though, so let's stick the other one down here. So there's its 7 electrons. I'm going to share this one and put a bond in between. And so now this chlorine also has 2, 4, 6, 8, and he is satisfied. I still have to get the sulfur in here, so we'll stick it over here. Sulfur has 6. So let's share these 2, and we'll bond the sulfur to the carbon. Did that take care of everything? Well, no, because if you look, the sulfur has 2, 4, 6, 7. So it's not satisfied, and the carbon isn't either because it has 2, 4, 6, 7. So they're both 1 short. So if I take this electron and I share them and make a double bond, I'll now have 2, 4, 6, 8 on the sulfur and 2, 4, 6, 8 on the carbon. Okay? So again, an example of a problem where the carbon needed the most electrons, and so that's the one that's going to end up in the middle. I have a couple more to look at here. Make some more space. One that's kind of similar to that is FNO, and then I have 3 different elements here. Again, think through this one. The fluorine needs, if you look, needs how many electrons? Just 1, because it's in that last column. The nitrogen has 5 electrons, so it needs 3. The oxygen has 6 electrons, and it needs 2. So this one needs 1, this one needs 3, this one needs 2. Now, you may not be able to do that quickly in your head. You might have to draw them out and say, okay, the fluorine looks like this, needs 1. The nitrogen looks like this, okay, it needs 3. The oxygen looks like that, and it needs 2. So since the nitrogen is the one that needs the most electrons, I'm putting it in the middle. So what can I bond together? Well, the fluorine just needs 1 more bond. 2, 4, 6, 8. It's now happy. If I bond the nitrogen and the oxygen together so that they're hooked, everything's hooked. Do I have it? 2, 4, 6, 7. The oxygen's not happy. Nitrogen has 2, 4, 6, 7 as well. It also needs 1 more. So if I take these 2 lone electrons and I combine them together in a bond, now my nitrogen has 2, 4, 6, 8, and the oxygen has 2, 4, 6, 8. So that's what the structure will look like for this compound. I wanted to show you one more because this one is just a tad bit different. You won't see this in many of the problems that you're working super often, but I do want you to see it. It's the compound carbon monosulfide. And if I look at the two dot structures, I have 4 on the carbon and I have 6 on the sulfur. So just like they're only hooking to each other. So I'm like, well, okay, we'll share those two together. I don't have an octet around either one of them yet. So if I share these 2 electrons and do it that way, my sulfur is now satisfied, 2, 4, 6, 8, but my carbon is not, 2, 4, 5, 6. It's still short. So what am I going to do now? Well, in this case, we're quite lucky that on occasion, atoms can be quite generous. And so the sulfur looks with pity on the carbon and he says, "Aw, you don't have enough." Tell you what, he says, "I'll take one of my pairs and I'll put it between us and we'll both share one of the pairs that I had by myself." Okay, so that's what happens in this particular case. This, again, I'll show you one more time. This pair was over here, but he takes this pair and he puts it in between the 2 of them as another bond. And so even though these electrons are being shared between them, they came from the sulfur only. So now this sulfur has 2, 4, 6, 8. The carbon has 2, 4, 6, 7, 8. A lot of times you will see this written with 2 electrons here, and they'll go ahead and pull these 2 electrons together and write them this way over here. Okay, so this is a special case where one electron takes its lone pair and shares them between the 2, but it does happen on occasion, and I think you have one problem like that in your homework assignment for today. So this just takes practice, so hang in there and keep working at it, and it will become easier.